Hi, welcome to Marker Board Videos. Today's video is about the 3 ways that we transfer heat. There are 3 ways that we generally study. The first way is called conduction, second way is convection, and the third one is radiation. So let's first talk about conduction. It's heat transfer within a material and between materials that are in direct contact. So they have to actually be literally in contact with one another for heat transfer to occur. A conductor is something that allows heat transfer to occur very easily, whereas an insulator resists that very same movement. It resists the movement of heat. So conduction, direct contact. Convection is the transfer of heat by movement of a heated substance. And I said a fluid, but I want you to know that fluid is not necessarily just a liquid. It could also be a gas. If you have a convection oven at home, then what's moving is the hot air, and as the hot air moves around, it warms up the food that's in your oven. Your lasagna is not in direct contact with the sides of the oven, but it still gets warm because it's in contact with the air that's moving around it. So that's called convection. And again, remember that energy and heat always flows from a hotter substance to a colder substance. Always goes from hotter to colder. The third way we talked about was radiation. And radiation is heat transfer in the form of electromagnetic rays. Now, when we think about the sun warming the earth, obviously we're not in direct contact with the sun, and we're too far for the warm air from the sun to actually come all the way to the earth and warm the earth. So what's actually happening is that energy is in the form of electromagnetic rays, and that gets through the earth's atmosphere and warms the earth. So radiant energy is what we call that. It's energy transmitted due to radiation. Now, I know that I told you I was going to tell you a story about heat transfer, so I'm going to tell you the story, and then I want you to think about which one of those 3 forms of heat transfer were used. When I was a little kid, I was about 4 years old, we had this big picnic every year in my neighborhood. Everybody in the neighborhood went. It was a huge deal. They had barbecue and food and ice cream and pop, and they had potato sack races and prizes, and it was great, and everybody was really excited to go there. Well, one year we got there a little bit late, and when we got there, one of my friends told me that she had a problem, that she was eating the ice cream, but that it was really, really cold. Now, I was 4, so what do you know about ice cream when you're 4? Other than it tastes delicious, not a whole lot. And they had this one ice cream that I absolutely loved. It was called the Dreamsicle. I think now we call them a creamsicle. It's that orange sherbet, you know, with the white vanilla ice cream in the middle. Anyway, they had those, and those are my favorite. In fact, I still love them. So I grabbed one and went to eat it, took it out of the paper and put it on my tongue, and it got stuck. It got stuck on my tongue. The ice cream, the popsicle thing, got stuck on my tongue. And I didn't know what to do because I was scared. So I yanked it off. I couldn't eat for weeks. Anything was very painful. Blood, tongue all over the ice cream. So what kind of heat transfer was that? Obviously, that was conduction. That heat was transferred between 2 objects that were in direct contact. My tongue had more heat than that popsicle. And remember, the popsicle had been stored in dry ice, so it was very, very cold. If you've ever watched the movie Christmas Story, you know about when things are really warm and things are really cold, they stick together. Well, that's exactly what happened. My tongue was warm, the ice cream was hot, my tongue was hot, the ice cream was cold, and the heat wanted to flow from a hot object to a cold object, but that was so cold, and it wanted that heat so badly that it refused to let go, that you could not separate the 2 easily. I paid the price for that. Later in the day, my dad had taken me and sat me up on the little table where they had the guy that was pouring the Cokes and stuff, and he sat me up on the table, and it was about I don't know, mid-chest, low-chest height. So he sat me on there, and he's talking to the guy next to him, and my dad was a smoker, so he's smoking like this, and he's talking, and he turns, and the lit, glowing end of his cigarette got embedded in my knee. Yeah. So for the second time in one day, I experienced heat transfer, a very painful way of experiencing heat transfer, but I experienced heat transfer. Yeah, I mean, he moved it right away, but the damage was done because, again, the cigarette was very, very hot compared to the temperature of my leg. Heat flowed from a hotter object to a cooler object, in this case from the glowing end of the cigarette into my leg, I still have a scar. That also was an example, painful example of conduction, energy transfer through direct contact. So hopefully you'll remember those two examples and you'll remember that. The other thing I want to talk to you about real quickly is states of matter, phases of matter, and it has to really do with two things. It's 4 phases of matter. You may have learned solid, liquid, gas. We're not going to talk too much about plasma. I want you to know that it exists, but we're not going to focus on that at all. It relies on 2 things. It relies on temperature and pressure. Now, most people say, well, water boils at 100 degrees Celsius or 212 Fahrenheit, and that's true, except you can actually have water boil at a much lower temperature if you simply change the air pressure, the pressure that that water is under. You can make it boil significantly lower. So the phase depends not only on the temperature but also the pressure that the substance is exposed to. It does involve an energy transfer. And if we go with solid, liquid, and gas, if we're going to go from solid to liquid or liquid to gas, we have to absorb energy. So that requires energy to occur. And if we're going from gas to liquid, liquid to solid, energy is released. So yes, sometimes we go from solid to gas, like dry ice. That would be an absorption of energy. We also go from gas to solid, and that's releasing energy.